All right, we're going to go through the last 5 problems of the multiple choice on the August 2015 Geometry Common Core exam. So let's look at number 20. It says a triangle is dilated by a scale factor of 3 with the center of dilation at the origin. Which statement is true? All right, so just a little information about dilation. If your scale factor is above 1, you're going to end up with a larger figure. If your scale factor is between 0 and 1, you're going to end up with a smaller figure for your image. Just a little information about that. So I want you to write this part down, these notes. When a figure is dilated, the slope of the corresponding sides are equal, and the corresponding angle measures are equal. So when you dilate a figure that has a scale factor of 3, so something like that approximately, your angle measures, corresponding angle measures are going to be equal. Also, the slope of this line and its corresponding side in the image is going to remain unchanged. So slope is going to remain the same, right? So now let's look at our answer choices. And first one says the area of the image is 9 times the area of the original triangle. Number 2 says the perimeter of the image is 9 times the perimeter of the original triangle. The slope of any side of the image is 3 times the slope of the corresponding side of the original triangle. And the measure of each angle in the image is 3 times the measure of this corresponding angle of the original triangle. Well, based on the note I just had you write down, 2 of these you should see that you can eliminate. So make sure and look at the ones you can eliminate. So hopefully you recognize 3 and 4 can be eliminated based on what I had you write down. The slopes of the corresponding sides are not going to change. The angle measures are not going to change. So now we're left with 1 and 2. So for this, I'm going to just go to my graph paper, and I'm going to graph a triangle and then get the image with a scale factor of 3. And I'm going to test out the area and the perimeter and see how the image compares to the pre-image. So I'm going to go over here to graph paper. Remember, you have this graph paper on your exam. Make sure and use it. So I'm going to graph any triangle. So I'll graph a triangle that has this point. That's -2, 0. This point is 2, 0. And then I'll do 0, 2. I'm just doing a general triangle because it doesn't give you specific points. It just says in general, if you take a triangle and dilate it with the center at the origin, which of these is going to be true, right? So let's go back to, right, which statement is true? So if it's true, it's always got to be true. I mean, no matter what triangle you're dealing with. So if it's always true, it'll be true with the triangle I just drew, okay? So now, a dilation of 3 with a scale factor of 3, that's going to be, remember, if you do a dilation of 3, what you're going to do is multiply each point by that number. So your new point for your image is going to be 6, 0 here, because I'm multiplying this by 3 and this by 3. So we're going to have 1, 2, 3, 4, 5, 6, 0. And then over here, it's going to be obviously -6, 0 for the image. So 2, 1, 2, 3, 4, 5, 6. And then this one's going to obviously be 0, 6. So, all right. So now here's my new triangle. All right, let's look at the perimeter of my original triangle. My original, because let's go back and look at the problem here. It says, well, let's look at area first. So it says the area of the image is 9 times the area of the original triangle. Let's go find the area of both these triangles. So the blue one, my pre-image, remember, area of a triangle, area of triangle is equal to 1/2 times base times height. 1/2 times base times height. Well, we know the base on this original one is 4, because I'm looking here 1, 2, 3, and 4. And the height is just going to be 1, 2. All right, so the area is going to equal 1/2 times 4 times 2, which is equal to 1/2 of 8, which is 4. So our area of our original was 4. Now let's look at the area of the image. So the image, the base is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here to here is 12. Area equals 1/2 times 12. And the height is now 6. All right, so if you notice, the base is 3 times as much as the original, and the height is 3 times as much. So our area is equal to 1/2 of 72, and the area is equal to 36. All right, if you look at the original area versus the new area, it looks like we have our answer. It looks like the area of the image is 9 times. So let's just try out number 2, though. The perimeter of the image is 9 times the perimeter of the original. So let's go back here, and let's approximate the perimeter. With our blue one, the perimeter is going to be, remember that bottom side is 4, and then the other 2 sides are about 2. Let's just say they're about 2. We're estimating. So it's approximately 8, give or take. It's a little bit more than 8 because actually these 2 sides, this side is actually a little bit more than 2, and this is a little more than 2, but it's approximate. Now, what about the bigger one? Well, the bigger one, the bottom, remember, is 12, and then these other ones, well, 1, 2, 3, 4, 5, 6, it's about 6 or 7. Let's just say 7. And both of them are about 7. Either way, even if you think that's 8 or 9, I mean, the perimeter is going to be around, based on the numbers I have, around 26, around there. So these are approximate numbers, but it's nowhere close to what they're saying in the problem. Is the perimeter of the image 9 times the perimeter? I mean, let's look. 9 times. If the original were 8, 9 times would be 72. All right, the perimeter of the image is nowhere near that. So that tells us right there that number 2 is not an option. All right, so we did that pretty quickly. I mean, we could actually find out the perimeter. We could just find what this length is exactly, and then this one would be the same, and we could add them up. But in general, just looking at it and estimating, we can tell that number 1 is our answer. All right? So let's move on to the next problem. All right, it says the Great Pyramid of Giza was constructed as a regular pyramid with a square base. It was built with an approximate volume of 2,592,276 cubic meters and a height of 146.5 meters. What was the length of one side of its base to the nearest meter? Well, remember, its base is a square. And remember, all those quizzes I've given you about formulas, if you go in the back of your test, it does say on the reference sheet, and I'm going back there right now, it does say on the reference sheet that a pyramid, the volume is 1/3 times B times H. What it doesn't say on your reference sheet is this part. You've got to know what the area of the base is. So when you're looking at a pyramid, it could have a triangular base, it could have a rectangular base, or it could have a square base. So you have to know what the base, you have to know that big B And I've been stressing this over and over. That big B stands for the area of the base. All right, so you're not actually looking for the volume. A lot of times in problems, you're looking for the volume. You know, you're given the height, you're given some other information, looking for the volume. When they make it a little more difficult is when they give you the volume and they have you look for something else. So let's go ahead. First of all, what is a square? Well, a square is a quadrilateral with 4 equal sides and 4 equal angles. And the area is equal to length times width, or base times height. Or you sometimes see it for a square, just side squared. So S squared. The reason why you can do that for a square is because if all the sides are the same, you know, for instance, if you have a square and all the sides are 4, the area is just going to be 4 squared, or side squared. So you might see it like that. Most students just think about base times height or length times width. So either way. All right, let's set it up then. Let's set it up. And you should be working on these on your own. Should be working on these on your own and then checking your answers. That's what I want you to be doing. All right, so we have the volume. The volume is right here. So we're actually going to plug that in. We're going to plug that in. All right, so we're going to plug that in for our volume. So we're going to have 2 million, right, 2,592,276 is equal to, so we're putting that in place of this, is equal to 1/3. Now, we don't know the base area, so we're just going to put in B here. And then times the height, which is 146.5. All right, so you want to get this big B by itself. This one I'm about to highlight. You want to get that by itself. Well, it's being multiplied by 1/3 and by 146.5. So you actually can divide this entire thing by 1/3 and 146.5, and then divide this side by the same thing, 1/3 and 146.5. All right, so I'm going to go on a calculator and do that. And so let's put it in. This is how I would put it in. We have, so I'm going to go calculator and then do my fraction here. So on the top, I'm going to have my 2592276, and on the bottom, I'm just going to go ahead and put the fraction here, because sometimes when you're dealing with fractions and you start using division, it can get kind of messy. And also, if you try and change that to a decimal, for some fractions it's okay, like, if you have like 1/4, you change that to 0.25, you're fine. But 1/3, if you try and just change that to 0.33, well, that's really not 0.33. It's 0.333, repeating. So you just got to be careful. So I'm just going to write it like this. 1/3 times 146.5, parenthesis. All right, so we end up with, this is big B. So we end up with B is equal to, write that down, 53084.15. So this 53084.15. Now, I'm writing this down right here, but I wouldn't even take it out of my calculator. Now, that is the area of the base. Remember, this big B stood for area of the base. So that's what we just found, the area of the base. Now, we're asked, what was the length of one side? Remember, this is a square. So whatever one length is, the other lengths have to be the same. So this is actually helpful to think about. One of the formulas that I talked about a couple minutes ago was S squared. In order to get the length of the side, instead of squaring it, if we know what the area is, we can take the square root. So the length of side is equal to the square root of big B. So I'm going to go in my calculator. I have not taken out the number, so I'm going to go second square, then I'm going to hit up, and I'm just going to enter in this entire number. I'm going to hit enter, and you get 230. So let's look at our answers. All right, there we go. 230, that is our answer. Let's look at number 22. Number 22 is a perfect one, a perfect problem to go in your graph. Now, I would say there are going to be at least 3 problems on this test where if you go to the graph, it's going to make it so much easier, and if you don't, you'll have a chance of getting it wrong. That could be the difference between passing and not passing. So use the graph. I cannot stress that enough. But what it's asking here is, a quadrilateral has vertices with coordinates -3, 1, 0, 3, 5, 2, and -1, -2. Which type of quadrilateral is this? Well, we've talked extensively about these 3. We haven't talked as much about trapezoids, but we know about 3 of those very well. So let's go and graph it and see what we have. We have -3, 1. We have 0, 3. We have 5 and 2, and -1, -2. Okay. Now, this is multiple choice. If this were a part 2 question, they asked to show why you think it is what it is, it'd be a lot more work. But looking at that, obviously that is not a square. And obviously it is not a rectangle. And if you remember, a rhombus has all sides being congruent. And we could, a quick check, you could tell. I mean, we could do the distance formula, or we could just, set up our a squared plus b squared here, a squared plus b squared. These are actually the same length, this one and this one. But this one over here is a different length, and this side's, this side's a different length, this side's a different length. So it's definitely not a rhombus, because remember, a rhombus has all sides the same length. So, not a rhombus, so it's a trapezoid by process of elimination. All right, let's look at number 23. It says in the diagram below, triangle ABE is the image of triangle ACD. After a dilation centered at the origin, the coordinates of the vertices are 0, 0, 3, 0, 4.50, 0, 6, and 0, 4. All right, so let's pay attention here. The important thing that you have to see is it says ABE is the image. And it's the image of ACD. So ACD, this was the pre-image. So we have a triangle that got smaller. So that means the scale factor must have been what? It had to be below 1, from 0 to 1. So that's a very important thing to think about. All right, so looking here, that means, okay, so now what's the question? Let's look at the question. So the ratio of the lengths of BE to CD, so BE is this one, BE to CD is what? Well, you need to think about, first of all, which one's longer. Obviously, CD is longer, right? That's obviously the longer side. So in a ratio, if they were the same size, you'd have a 1-to-1 ratio, or 4-to-4, or 3-to-3, if they're the same size. But since CD is bigger and BE is small, now look here, it says the ratio of BE to CD. All right, so that means you need to have a ratio that is below 1. All right, if it were the other way around, you'd want a ratio of above 1. All right, so there's so many ways to do this. But we can eliminate, knowing we need a ratio below 1, we can already eliminate 2 of them. Hopefully you see which ones. Take a second. If you guess 2 and 3 can be eliminated, 2 and 4 could be eliminated, you'd be right. All right, so now how are we going to find out if it's 1 or 3? Well, let's look here. We have, maybe we can even find the length of BE. Maybe we can actually find the length. So let's erase, I'm going to erase some of this now. And go back and can we find BE? Well, we have a right triangle here. That means that we could use a squared plus b squared equals c squared. So we know that's 3, we know that's 4. If you remember, our special triangles, this is going to be 5. And let's see, this other one, we have 1, 2, 3, 4. This is 4.5. So this one down here, we know is 4.5 because from A to C, remember this point is 4.5. And D is 6. So we would do 6 squared plus 4.5 squared is equal to x squared. So we have 36 plus 4.5 squared. I'm going to take a break for a second. Maybe you could try this. All right, once you do all that, you end up getting x is equal to 7.5. So this length here is 7.5. So if you look and say, okay, 5 over 7.5. Well, if you put that in the calculator, you can see that that is actually 2 over 3. It's the same as 2 over 3. If you think about, if you divide this by 2.5, divide this by 2.5, you get 2 over 3. All right. So I'm going to show you a different way, though. And as I was working through that, I was thinking this isn't the easiest way. Remember the ratio. Let's look at a couple things here. If we know this side, the corresponding sides have to be proportional, and they're going to be in the same proportion. So you have this one is 3, and then this one here is 4.5 for the bigger triangle there. 4.5. So you have 3 over 4.5. And then here you have, this is the easiest one actually. If you go up and down, that's going to be 4. And then the whole thing is 6 on the bigger triangle. So 4 is 6. And they all should be the same. If you reduce 3 over 4.5, it's 2 over 3. If you reduce 4 over 6, it's 2 over 3. And as we just showed here, if you reduce 5 over 7.5, it's still 2 over 3. All right? Let's move to our last one. All right, we haven't talked about this much, and I'm not going to spend too much time on this, but I will go over a couple things about it. It says line y equals 3x minus 1 is transformed by a dilation with a scale factor of 2 and centered at 3,8. The line's image is, well, let's look at this point 3,8. Let's see if it's on the line. If it's on the line, then the y-intercept is not going to change. So how do we figure that out? Well, we plug in 3 for x and 8 for y, and see if that is true. If that's true, then this point is actually on this line. So let's do 8 equals 3 times 3 minus 1, 8 is equal to 8. Well, look at there. That point is actually on the line, which means that the y-intercept will not change. And in fact, we have actually this same equation. All right, and I want you to write this down right here. And what you see right here, since the line contains the center of dilation, the y-intercept is unchanged. I want you to write that down. All right? And there you go. That's the end of the multiple choice problems.